Flack math! Give me some math and I'll give you some flack. Flack math!
So this is lesson 41. So we are gonna just do a little bit of review here. A statement showing that two ratios are equal is called what? Can you shout it out? A proportion, inequality, or direct variation?
What?
Dividing.
Showing that two ratios.
You're
What do you
reading
think?
that sentence here.
What sentence?
A statement showing that two ratios are equal is called a. That's a little hard. Is that the?
So like this, what is this called?
A fraction?
There are two fractions, two equivalent ratios. So
No
what is
idea.
that called?
Proportional something.
Yeah, they're proportions. Good job. All right, is this statement true or false? If all three sides of one triangle are congruent to all three sides of another triangle, the triangles are congruent. Is that true or false?
True.
True.
Why?
No idea.
Because all the sides are equal.
SSS.
Yes, SSS.
I got that right. Mm-hmm.
Yep. So SSS theorem or postulate, if that's what that says. Okay. Given ABC is congruent to DEF, tell which sides are congruent. Can you tell?
I can't be.
Wait, where are we looking?
Oh.
So number
Problem number
three.
three.
Right here. So they're lined up. They should be in the right order. So you can say that like AB is congruent to DE, right? You can say that BC is congruent to EF. So see how they correspond to each other so that they're written in this order for a reason. So A corresponds with D, B corresponds with E, C corresponds with F. Okay, and then of course, AC has to be congruent to DF. You can do angles as well. So angle A is congruent to angle D, angle B is congruent to angle E, and so on, okay? All right, so the last one, if triangle XYZ and CAM, if those angles,
Phones away.
what's that?
Put the phones away.
Oh. Okay, so let's see, an angle is congruent, and then a side is congruent, and then another angle. Okay, which postulate or theorem can prove that these triangles are congruent?
ASA.
ASA, that's right. So if that side XY is in between X and Y, and it is, it's inclusive. So ASA. All right, good job. Okay, so here's 41. A ratio is a comparison of two values by division. Okay. Now, a lot of people confuse a ratio with a fraction. Even though a ratio can be written like a fraction. When I think of a fraction, I think of a certain amount out of a total. And that's not necessarily what a ratio is. It can be if I was comparing the number of girls in the class to the total number in the class, that's a ratio. But if I was comparing the number of girls in the class to the number of boys in the class, that's a ratio. So how many girls are in the class?
6.
6?
6.
How many boys in the class?
Currently 3.
3. Okay, so it's a 6-to-3 ratio. You can still write it like this, but what fraction of the class are girls?
6 out of 9.
Yeah, 6 out of 9, and then 3 out of 9 are boys. Okay, so do you guys understand the difference between a ratio and a fraction?
Yes.
Okay, technically there shouldn't be, but there is. It just depends on how you word it. Okay, so writing ratios and proportions. So consider the triangle MNO and PQR. All right, so if all the angles are congruent, that means that these triangles have the same shape, but different size. So it's kind of like I zoomed in to this triangle to get this. So these are similar triangles. These are proportionate. So all the sides are proportionate to each other. So do you see how the ratio of the sides is like 5 is to 10, as 3 is to 6, as 7 is to 14. All the side lengths are twice as long as these sides, okay? So mn to no, let's see, mn to no. So I could write a ratio of all three of these to each other. I could say 5 is to 7 is to 3. Okay, so this is like a three-part ratio. All right, and then this guy is 10 is to 14 is to 6. Okay. So you can write ratios like that as well. Now these colons and they're kind of confusing. So I'm going to show you a different way to do this, and you can write it this way if you want, or you can write it my way. So so mn to pq in 3 different ways. So you can write it with words. You can write it 5 to 10. You can write it with colon 5 to 10, or you can write it as a fraction. And then if you write it as a fraction, and if you write it to any of these, you can always reduce it. So you can always say 1 to 2. It's a 1 to 2 ratio. A 5 to 10 ratio is the same thing as a 1 to 2 ratio, or 1 to 2, or 1 to 2. Okay. All right. So here's a proportion. Write a proportion to show that mn is to pq as no is to qr. So all you're doing is just substituting the values in there and writing it like that. Okay. Now here's something new. And remember the fish method? You can always figure out the missing part of a ratio by using the fish method. So 7 times 10 divided by 5 is 14. Or 5 times 14 divided by 10 is 7. Okay. So that's the fish method. So because the cross products have to be congruent, have to be equal. All right, so this is a new concept. The extremes are the top left and the bottom right. And then the means are the bottom left and the top right. Okay, so those are the means. So when it just depends on how it's labeled. So in this proportion here, what are the means to this proportion? So up here, see this 5 is to 10 and 7 is to 14. What are the means of this proportion?
Half? Oh no, sorry. Wait, never mind. I was looking at the 5 to 10, 5 to 10, 5. Sorry, I wasn't looking at that. I was looking at the one above it. I'm really sorry.
That's all right.
What was the question?
So the means of this proportion, remember, are the bottom left and top right. So just 10 and 7 or 7 and 10. Okay. So the product, the cross product of the means and the product of the extremes always has to be equal. So in this case, this is what you already know. This is basically the fish method. So AD has to equal BC. Those cross products have to be the same in every proportion. If the proportion is true, if there's an equal sign in between the two ratios, then the cross products have to be equal. So this is where the fish method comes in. So 3 times 50 has to equal 15 times x, right? So 3 times 50 is 150. So 15 times x has to equal 150. And a fast way to do that is just multiply, figure out the only cross product you can right now, which is this one, the extremes, and then divide by 15 to figure out your missing number. 3 times 50 is 150 divided by 15 equals 10. The other Mr. Flack doesn't like the fish method. I don't know. He had a bad experience with fish when he was a young child boy, but so he doesn't like the fish method. I don't even know if he likes seafood. He's just weird, okay?
I hate
But
seafood. I love seafood.
what he would do is just write out the cross products. So 15, what's that?
You make it.
You're cutting out.
What was the question?
So there's not a question. this is another way to do this, the cross product. So you could just write out the cross product. So 15 times x has to equal 3 times 50. And then simplify and solve. 15x equals 150. Divide by 15. So either way, you're dividing 150 by 15 to get 10. Okay. So if the fish method is confusing to you, or you had a bad experience with fish when you were a young child person, then, you know, write it out. Just write out the two cross products and set them equal to each other, and then solve for the missing number. Okay. All right. So this is a definition you've heard before. This is similar. So similar means same size, different shape. I almost said same size, different shape. Okay. Same shape, different size. Did I say same size, different shape? That doesn't even make sense. It's the same shape, different size. So see how these have the same shape, but they're different sizes. Okay. So we would call these triangles similar. All right. So similar polygons, the corresponding angles are congruent, but the sides are not congruent, but they are proportionate. So see how 6 is twice as long as 3, 4 is twice as long as 2, 10 is twice as long as 5. I always talk about like model airplanes or model, when you build a model, there's always an X factor on top on the box that says like X30 or something, which means that the model airplane that you're putting together is 30 times smaller than the actual size of the airplane. Okay. So they're just proportionate. That's what it means to be proportionate. Okay. They're not the same. They're not congruent. The sides aren't congruent, but the angles are. The angles are congruent. So if this was a 92-degree angle, angle A, then angle D would have to be a 92-degree angle. Okay. So similar polygons, corresponding angles are congruent. That's what we just said. And then the corresponding sides are not congruent, but they're proportional. So in triangle ABC, all have congruent angles, but each pair of their corresponding sides has the same proportion relationship. So if I compare these relationships, like DE is to AB, so 6 is to 3, as EF is to BC, so 10 is to 5. So do you see these proportions down here? Oops, I kind of messed up that. All right, so here's in similarity. So does somebody have a question? Okay, so similarity.
It like cut out a lot.
What's that? You good?
The connection is unstable.
Oh,
Once in a while, you're cutting out.
okay. I keep stopping to talk because I hear you say something. So am I still good?
Yeah.
Yeah.
Okay, good.
It wasn't great.
All right.
It wasn't a great connection. It's true.
So if you guys have a question, raise your hand, and then I'll stop talking. But so like congruence, similarity is a transitive relationship. Okay, so the transitive property, remember, if A is equal to B and B is equal to C, then A equals C. So if the first thing is congruent to the second part, and the second thing is congruent to the third thing, that means the first thing has to be congruent to all the way to the end, the third thing. Okay. So similarity works the same way. If A is similar to B and B is similar to C, then A has to be similar to C. So if I drew another triangle here that looked like these two triangles, and I said, okay, if this triangle is similar to this triangle, and this triangle is similar to this triangle, that means this first triangle is similar to this last triangle. It's just a different scale factor. It's a little bit bigger than ×2, okay? So that's the transitive property of similarity. Okay, so let's see if we can figure out the missing sides here. So I'm gonna zoom in so you don't see the solution. Okay, see if you can find A and B. Take a minute or two and see if you can find A and B, and I'll work over here slowly off to the side I don't want to get ahead of you, so don't let me get ahead of you. All right, let's see here. 5 goes with A. And
5 would be 20.
4 goes with 16. So all I did was line these up, 5 on top of A and then 4 on top of 16. Okay, and then I could say 7 on top of B. Okay, just don't reverse the order. So don't say 5 over A is 16 over 4. Make sure the smaller triangle's on top and the bigger triangle's on bottom, or vice versa. Okay, so what I'm going to do is I'm going to work on this proportion here and find the missing number. So it looks like if I go 5 times 16 and divide by 4, 5 times 16 is 80 divided by 4. That should be 20. Okay, that sounds right. And then I'm going to come over here and work on the B here. So I'm going to use this same 4 over 16 to figure out this. So I'm going to go 7 times 16 divided by 4. That's going to be 28. 7 times 16 is 100. 112 divided by 4 is, yeah, 20. Not 28. Is it 28? Should be 28. Yeah. So can anyone think of an easier way to do this? Because I just spent a lot of brain power on that, and then I looked at the diagram and I'm like, wait a minute, there's an easier way to do this. Can anyone tell me the easier way to do this?
Times each side by 4.
Yeah, so this just has, you could use the proportion method. You can set up proportions, or you can look to see if there's a scale factor. Yes, because look, 4 times 4 equals 16. So we're going to multiply all the sides by 4, because we're just multiplying this whole shape by a factor of 4. Okay, so 5 times 4 is 20. Oh, that would have made that easier. 4 times 4 is 16. We already knew that. 7 times 4 is 28. That would definitely have made this confusing math easier, right? So you can do it that way. Here's the way I would suggest to do these problems. Now, look at all these confusing proportions. You can do that if you want, or you can set up a ratio box. And we've done this before in other classes, but this is what a ratio box is. I'm going to set up tic-tac-toe here. When you don't know, tic-tac-toe. So you can set up, you can put all your dimensions in here if you want. You can go vertical, you can go horizontal, it doesn't matter. So I'm going to go vertical here, 5, 4, 7. So this is the small triangle. Okay, this is the big triangle. So make sure you go in the same order, left, right, bottom. So this is left. If you want to label it, you can. This is bottom. So in the big triangle, left side is A, the right side is 16, and the bottom is B. Okay, so now look, I've got my proportions already set up. So I can fish it home, do it that, or I can use the scale factor. 4 times 4 is 16. So 5 times 4 is 20, and 7 times 4 is 28. You could do it that way, or you could use the scale, or you could use the fish method. So see how the proportions are right here, and you could just do that. And you can also do it over here. I'm running out of colors. You do it there too, and figure out the same way, okay? So when you're dealing with proportions, it really doesn't matter how you do it. Just make sure you're consistent and you write things in the correct order. Okay, so similarity statement is a lot like congruence, except it looks a little different. So this is the symbol for congruent. That looks ugly. This is the symbol for equals, right? And then this is the symbol for similarity or similar. Now, here's what's cool about these symbols. So congruent means same, so equal measures and same shape, right? Well, similar means same shape, equal means equal. So see how congruent is equal and similar. So it has the same shape, similar, and the same size, equal. So see how they combine those two symbols to make the congruent symbol. So that's pretty cool. All right, so if I were to name things, this is what they would look like. So these, if these quadrilaterals are similar, you just put a little squiggly in between those. So quad STUV is similar to WXYZ. And again, you have to be congruent. So it looks like this guy is the sharpest point here. So make sure that W lines up with S. All right, and then it goes around this way, it looks like. So make sure that Z lines up with, oh no, it flipped, didn't it? So you kind of have to do the math and figure out what goes with what. So if this is 110 and this is 125, so this means this is 125 over here, and then this is 110 right here. So you're going from W in the direction of 125. So W goes with S. So S has to go in the direction of V, which is 125. So V goes with Z there. Okay. So you have to be careful, especially with something like this, where it's hard to tell which direction they're going. So they flipped it around and they shrunk it. So, so you have to figure out the measures of T and Z. We just did that because if these are similar, then that has to, all the angles have to be the same. Or they have to be the same measure, congruent. Okay. That feel all right there? Angles are nice because they're just congruent angles. So just match it up, fill out the puzzle. Okay, what's the length of YZ? Well, can we figure out the scale factor? Well, the scale factor isn't as pretty, unfortunately. So it looks like we've got a ratio here. So if I did a big to small, then I could go 15. And then we've got our YZ here. So that's, we're just gonna put our variable there. 15 is to YZ as 6 is to 4. Okay, so now if I use the fish method, 5 times 14 divided by 6 is 10. Okay, so see how going from 6 to 15, there's not a nice scale factor. It's actually times 2.5. Well, that's not, well, I mean, I guess you could do that. 4 times 2.5 would be 10 as well. So you could still use the scale factor. It's just a decimal, or it might not be a pretty number to multiply by. Okay, that was example 4. All right, let's move on to the next lesson, 42. Undoing this. It'll let me. Oh, guys. How come sometimes I can undo it?
Yes, you can.
Okay, getting rid of that. Let's go to the next lesson. All right. All right, so this is 42. Do a little bit of review here. 2 lines that meet at 90 degrees are what kind of lines? Yeah, shout it out.
Anybody? What was the question? Say the question again.
2 lines that meet at 90 degrees are what kind of lines?
Oh, right angle. Or wait, never mind.
Yeah, they form right angles. Good job. But they're perpendicular. When you're talking about the lines, they're perpendicular. Good job. State the formula for the Pythagorean theorem. What's the formula for the Pythagorean theorem?
A squared equals C squared.
Good job. All right. Formula to find the distance between 2 points. You guys remember that one?
Isn't it x1 over, wait, no, x1 plus x2 over 2?
So that's the finding the midpoint of a line segment. So that's what you did on the last test, x1 plus x2 over 2, and then comma, y1 plus y2 over 2. But the distance formula is just calculating the distance between the x's, squaring it, calculating the distance between the y's and squaring it. And then this is just the Pythagorean theorem, just without having to graph it, okay? So we'll talk about that in a second here. So what is the slope of this line? Do you remember the slope and what's the slope and what's the intercept? Can you guys remember how to figure out what the slope is and what the intercept is?
X plus B.
So the slope is whatever number is being multiplied by the x, but only when y is by itself. Since this is in slope-intercept form, is y equals slope x plus y-intercept. So the slope is 3. The y-intercept, it's not asking this, the y-intercept is the constant, which is 1. So if I were to graph this, I go up to 1 on the y-intercept, and then I follow a slope of 3. So up 3 over 1, up 3 over 1. Okay, we'll do more of this later, but this is just a little bit of review. Perpendicular slope. Do you know how to calculate perpendicular slope? Well, parallel slopes have the same slope. But perpendicular is you flip it and you negate it. So you flip 2 over 1 and it's 1/2, and then you negate the negative to a positive and it's 1/2. So you flip and negate. So this is the negative reciprocal or negated reciprocal. And we'll do more of that here. So this is just some algebra review, but we'll get into our lesson here and it'll come together. So given a line AB and a point, so here's line AB and a point P that's not on the line. The shortest distance between P and AB is the perpendicular distance. So you have to go, so you can draw other lines that go from P to that line, but they're going to be longer than the one that's perpendicular to the line. Okay. So the shortest distance is going to be the perpendicular distance. Okay. All right. So the closest point. So for example, which point on the line y equals 0, so the x-axis, is closest to point D? Well, you have to draw a line that's perpendicular to the x-axis to D. Okay. Well, this one's nice because it's just straight up. Perpendicular is just straight up, so you just count the points. 1, 2, 3, 4, 5, 6. So 6 units up. That made it kind of nice. Okay. To D, let me see, which point on the line? So that means that would be, this is the perpendicular distance, so it's 4, 0, right? Okay. So see how these lines are longer and they look longer, don't they? So it's obvious that the shortest line has to be the one that's perpendicular to that line. Okay. So, and then you can figure out the points. Well, if it's just a vertical line, you just count the boxes, right? But you could use the distance formula. You have to calculate the difference of the x's. So 4 minus 4, which is 0. And they use the distance formula to test out all 3 of those. Well, that's no fun. Okay. All right. So here's theorem 42.1. Write this down. Through a line and a point not on a line. This is what we just talked about. There exists exactly one perpendicular line to a given line. Okay. So here's a line. Here's a point not on a line. There's only one line I can draw that's perpendicular. Okay, so theorem 42.2, the perpendicular segment from a point to a line is the shortest segment from the point to the line, okay? So basically, if we talked about this diagram again, this is the shortest part, shortest distance. Shortest segment is right here. Okay, if I draw a line from point P to anywhere else on the line, then it's going to be longer than this one. Okay. What are you guys doing?
Oh, sorry. There's this thing that's turning, and you go, hey. And people do it back like, hey. And you, hey. Hey.
Okay.
What?
Sorry.
Yeah, that's going to last forever, that trend.
It is. Hey.
Okay, so do you guys understand the two theorems? First of all, there's only one perpendicular line that you can draw that goes from the point to the line. And then that line that you draw, that line segment, is the shortest distance from the point not on the line to the line. Okay. All right. So now back down to the nitty gritty. Find the distance from 6,4 to line y equals 1. Well, this is nice because y equals 1 is just a horizontal line. So see this line? That's y equals 1. So you can literally just look at the graph and count it, right? So the distance between 6,4 and this line is 1, 2, 3 units. That's nice. But you could use the distance formula if you wanted to here. But here's another one. This is so that's distance A. So it's 3 units. So find the distance from 6,4 to line x equals 1. Okay, so x equals 1 is right here. X equals 1 is this line. Okay, this is x equals 1. So what's the distance from 6,4 to x equals 1?
3.
What's that?
3.
Not 3. So we're still going from this point here. So we're going 1, 2, the perpendicular distance for 5 units. Does that make sense? So we're going to the pink line. We're not going to the y equals 1 line, the blue line there. We're not going here. We're going to the pink line from this point. So that's just 5 units away. Okay. All right. What about the distance from 6,4 to y equals x? Well, y equals x looks like this. Y equals x is where everywhere on this line, y and x are the same value. So let me do something fancy here. So this is what y equals x looks like. Okay, so what's the distance from 6, 4 to this y equals x? Well, that's a little bit tricky. So how do you calculate this distance? It's not one box, because remember that diagonal is longer than the actual box. So how do you figure that out? What would you do? Any ideas?
Distance formula.
Yeah, you can use the distance formula. Well, I can see that the perpendicular thing there is, what is that, 5, 5. But if I zoom in real big, I can draw a little triangle. So what does that triangle look like? That's just 1 unit and 1 unit. So how do you figure out this third side of a right triangle? Well, a squared plus b squared equals c squared. There's a shortcut that we'll learn later. But that's just 1 squared, which is 1, So 1 plus 1 equals c squared. So 2 equals c squared. So c equals the square root of 2. And guess what? That's the answer. If it's not, it's going to be real embarrassing. But yeah. Okay. So now this one was nice because you didn't really have to figure out slope and stuff. You could just figure out that we just needed that distance there. Okay. When you do have to figure out slope, that becomes a more complicated problem, but we're not going to have any problems like that. At least we're not going to have them on the test. Okay. But here's an example of one of those problems. Okay. So this, you won't be tested on something like this, but this is about as complicated as it will ever get for finding the distance. Okay. So let's see if we can figure this out. Find the closest point on a line to a point. All right, so we want to figure out this distance right here, right? We're trying to figure out that distance. Well, we do know that's a triangle. So we can figure out that third side. So what are the units there? That's 2, that's 1. So this distance is just the square root of 2 squared plus 1 squared. So that's just the square root of 5. Well, that made it pretty nice. Now, it helped because we graphed it. When you graph it, and then the other thing that helped was trying to figure out this point here. Well, we can kind of see that that's perpendicular to that point, but that's not what they give you. So what they have to do first is you have to graph the line and figure out this line and figure out where they intersect. Okay. So given the equation y equals 2x plus 1 and the point 3, 2, find the point on the line that is closest to S. Okay. So we have to figure out where they intersect. So if this is a 2/1 slope, the perpendicular slope is going to be -1/2. You see how I got -1/2? I flipped it and I negated it. I flip and negated it. So going from 3, 2, you go down 1/2, down 1/2, down 1/2, or you go left 2, up 1, left 2, up 1. So do you see where they intersect? Right there at 1, 3. So that's our answer. So you have to figure out the perpendicular slope and then draw that slope from the point that you're given. Okay, so from here, go in the direction of -1/2 in both directions. Okay. All right, let's see if there's another one like that. That was a good one. And then you can still find the distance. And that's the other part of that. Okay, these are some theorems. You can write these down. The perpendicular segment from a point to a plane is the shortest segment from the point to the plane. This is going beyond points and lines to points and planes. Okay, so if this was a plane here and this was P, the shortest distance is going to be the perpendicular distance. So do you see the plane there and then the point not on the plane? If I dropped it straight down perpendicularly, then that would be the shortest distance. And that's always the shortest distance. If you're up in the air and you fall, the shortest distance is straight down, 90-degree angle, perpendicular. Okay, and then 42.4. If two lines are parallel, then all the points on one line are equidistant from points on the other line. Okay, so if here's two lines here that are parallel, then these points are equidistant. So for example, if this is 4, then this would have to be 4. This would have to be 4. Okay, they're the same distance apart. When we talk about the distance between two lines, especially parallel lines, we talk about the perpendicular distance. Okay, does everyone have those theorems? I will zoom out just in case you need to keep any of that. Oh, maybe not. Okay, so this is proving all points on parallel lines are equidistant. This is the theorem that we just had. We're just going to walk through this proof. I'm not going to have you do it, but here's what I'm going to do. I'm going to draw, we just drew a diagram, and then we're going to try to prove that AC is congruent to BD. So see how these lines are parallel. So we're going to try to prove that AC is congruent. The distance from A to C is equal to the distance between B and D. And that would prove our theorem. Okay, so what we did is we created this quadrilateral. Okay, and so what we're going to do is we're going to draw a diagram like this. M is parallel to N. That's what we're given because that's the if part of our statement. All right, and then we're going to say that CAB is congruent to BDC. Why? Because all right angles are congruent. These are perpendicular lines. So when we talk about the distance between two lines, we're talking about the perpendicular distance. So AC is a perpendicular line. Okay. And we can also say that angle ABC, you see this angle right here, is congruent to this angle. Why can you say that? Anyone know? Anyone remember? Because when you have parallel lines and a transversal, the alternate interior angles are congruent. Okay, so now we have two angles that are congruent. And then we have, let's see here, BC, this guy is congruent to itself. Why? Because of the reflexive property. That's what he sees in the mirror, is himself. So something is always, so now we've got AAS. So we can use that to prove that these two triangles are congruent. Well, that was a lot of work, but now what we can say is since these two triangles are congruent, all their corresponding parts are congruent. So QED, these two line segments have to be congruent because of CPCTC, right? Corresponding parts of congruent triangles are congruent. Okay, so that was a 6-step proof, which proves something that we kind of already knew in our guts, that the distance between every point on two parallel lines are the same. But this proof proves it. So now we can sleep better at night. Okay, that's it for 41 and 42. Here's the deal. We've got one more test for this semester. So I want you guys to, we're gonna review for the test starting next week. So if you get the practice test done, which is already uploaded in next week's folder, then you will get 10 points. All right. So if you get it done by Tuesday, you'll get 10 points extra credit on your practice test and your test. If you blow it and you get it done by Thursday instead, then you still get 5 points, but go for the 10, go big. Okay. Any questions on that?
Yes, we're all good.
Okay, good, good. All right. All right, so I'm gonna sign off. You guys have a few minutes if you want to get started on your homework. You can do that, or you could even start on a practice test. Oh, actually homework wouldn't work. But what do you guys want to project on the TV? I can send it over there. Anything? Or I mean, you guys don't have to work too. You could just rest your brains.
Yeah, like rest it for a little bit. I feel a headache coming on. A lot of math.
Okay. All right. Well, good job.
Happy early birthday.
Thank you.
Yeah, happy birthday. Happy birthday.
Thank you. You
Bye.
too. All right. I'll see you later.
Have a wonderful weekend.
You
Bye.
too.